Hello and welcome to day 3 of finals week. Only one more day to go after this. It's great to have so many of you joining with us as well to hear the work that our students have done over this summer. Today is focused around Mifos X, our core banking solution. So all of the presentations you'll hear today will have direct impact into our upstream Mifos X code base over the coming months as we do releases. So it's great to actually see the level of work these students have done in some quite innovative areas that really will take the project forwards. The project students we've got today are covering all of our different programs that we participated in. So Google Summer of Code, Code for GovTech, as well as the Mifos Summer of Code. So it's quite good what we've been able to do with the interns we have with us. Without much ado, we'll hand over to Gopi. But first of all, Ed, is there any words you would like to say?
Yeah, thank you, David. Really looking forward to the finals week showcases we have today. As David noted, they're going to cut across a variety of the capabilities on the Mifos X core banking system. So Gopi and Craig are going to kick off with some of the front end work they've been doing around the user interfaces and optimizing the user experience for all of our users. And then we'll round out today's sessions with a number of showcases looking at the various tools that our interns have been working on to help with credit decisioning and helping to properly analyze the risk of borrowers across a number of different projects that have been ongoing in development in the community, as well as a number of new modules that have been developed in response to the various needs that the community has. But without further ado, we'll pass it on to Gopi, who's going to highlight the efforts he has led along with Felix and other members of the community in enhancing the web app, the primary app that end users and system users use to interact with Mifos.
Hello everyone. My name is Gopi. Hope you all are doing well. I am Google Summer of Code intern. So my project is investment to Mifos X web app. My mentor is and today I will show you till now. Okay, so first of all, I will give you my overview of what was in my project. So in my project, I have to upgrade Angular from version 14 to 19 and improve overall UI design and layout. And also the second main thing was transaction to TypeScript client for auto-generated API. Right now we are using custom APIs, so there was like many human errors, and there was like many work. We have to write many line of code uh, for custom API. But after converting to auto-generated API, we do not have to write any single line of code. And fourth one was fixing key usability issue, identify the community. If any community member have any issue, so I was focusing on that, and first priority was mine to fix that. Okay. Okay, so I will show you my work progress. So first of all, I did Angular upgrade. This was my I completed this in midterm evaluation, and second main thing, auto generated API integration I did after midterm evaluation to final evaluation. So in till midterm evaluation, I upgrade Angular from 14 to 19, and it was like step by step, 14 to 15, then 16, then up to 19. In that all process, there was many things that broke, like all UI broke, and many dependencies, and like web app was not able to run, and many error come. So it take minimum 2 months, I guess so. So this was I mean not a easy task, but I with the help of Felix, I did it. And I created like many global CSS class to replace common pattern, and I with the help of GitHub Copilot and many things. So I completed, and after that, still there is some pages have issues with UI, but I'm also working on that. But overall, we have now Angular 19 in our web app. Soon we will upgrade it to 20 in November and or December. So this was my till journey midterm. So after midterm, I focus on auto-generated API integration. This was second main thing. In this, we have many custom API services. So I generate one file finrect.html from backend. Then after that, we have one command to generate packages. I mean, many service files or auto generate API from one command. So I generated that. I will show you this one. It auto generate many services and models APIs. So we do not have to write code. I mean, we do not have to write. After that generated, I have to replace all custom API with auto generated. So I will like go by one service to there is many service like 15 around 15 services. So let's take a client.service.ts. I take that and in that there is was many custom API. So one by one I replaced all of them. This was a long process, but after understanding it was easy, not hard. Sometimes it was hard, but I will connect with many Mifos members and mentors, and I solved it. And also after that, this package fingerprint client, we have to when we install our setup web app, we do clone and like npm install. Then we have to run one more command, which was npm run generate fingerprint client. So this was like not a good practice. So what did I do? I create a separate repo of fingerprint client, this one, and push this old code there. Then I hosted that old repo on npm. So from this I just run this npm I fingerprint client in my terminal, and all code come in my node modules. So we do not have to run this command npm run generate fingerprint client every time when we set up code or any new contributor comes. So just we have to now right now we have to do uh, npm install, and it will automatically uh, do something. I mean, uh, fetch these services in node modules. Okay, so this was my work progress, all of, and future work. Okay, before future work, I will show you this one. Okay, so if you search hosted this, and this have 1.0.4 version. Okay, you can see GK. Okay, so I hosted here, and from here I released 1.0.4 version and hosted on npm. And then in package.json I just put here a fingerprint client, and then just we can click on npm install, and it will take all of your code in node modules. Okay, then we will come to our future work. Okay, so in future work, I am thinking to implement code rabbit, which will review our code efficiently whenever someone raise PR over. So automatically code rabbit will triggered, and it will review code, and it will help the mentor. So mentor do not have to sit and read everything code. It will help mentor a lot. Also, I'm implementing code which will automatically test code and will read code coverage. And if the code coverage is less than, let's take, if we implement like 70%, so it do not it will fail the workflow, and it will do not push that PR in our code if their test quality and or code quality is low. So these two things is, I mean, according to me, is best. Many it is open source, and all of many users use. This is code rabbit. It will automatically review code and help mentors and code quality. And this one is code which will read code coverage. And this is also I mean, according to it is best thing. And okay, so this is my progress till now, and I am very thankful to my mentor Felix and David, Victor, and Ed Cable. And thank you all for the help. Thanks.
Thank you, Gopi, for showcasing those efforts. It's really great to have that auto-generated client now in place, and we look forward to the ongoing enhancements that the rest of the community will be able to make into the web app with Felix, yourself, and look forward to your continued contributions. And thank you for everything you worked on this summer. Next up, we're going to continue focusing on the front end, and we're going to pass it on to Craig, who's been working on a next generation React-based UI with more modular components that will help to enable the variety of different use cases that are built on top of Mifos X to have a more tailored and optimized user experience. And Craig has been working under the mentorship of Alex Vidakovich. So on to you, Craig, and really looking forward to seeing everything you were able to accomplish throughout the summer.
Hello everyone. My name is Craig, and in the past summer I've been working on new modern web UI for the Mifos X web app. It will be a new React-based web app. So let me just tell you the contents in this slide. We will go over the project overview, the work progress, the structure, and future work, as well as a short demo. Build once, reuse everyone. That's the code. Okay, the project overview. Basically, this shows whatever tech stack I've used in this project. Obviously, React and TypeScript for the front end. Tailwind CSS as well as ShadCN was used to make custom components as well as styling. Redux was used for global state management, and Apache Fineract for the backend integration. The work progress during the midterms, I had completed the sidebar pages, which included the dashboard, navigation, checker inbox and tasks, notification, and other small pages like profile. After the final evaluation, I have completed the entire admin module, which consists of 4 other modules, which is users, organization, products, and templates. Then I have finished majority of the reports module, which include client loan savings, funds, and accounting, as well as the accounting module, which had closing entries, accounting rules, etc. Also, I've finished majority of the institution module, which has 3 other modules in it, which is client, centers, and groups, which have different types of accounts like loan accounts, savings accounts, and share accounts, which have different types of sub pages based on what is the status of the account. And all in all, I've completed over 200 plus different screens and connected them to the Fineract backend. So this is just a rough layout of how the whole project is sorted in the new React web app. The app contains the Redux toolkit. The assets contain all the images. The components have 2 main folders. The UI folder is for the ShadCN components, and the custom folder is the custom components that I have created. The Finirect API contains a Finirect TypeScript generated client. The layout contains the navbar and the sidebar layout, and the pages contain the pages for the web app. It strongly resembles what we have currently in the Angular web app. The router contains all the routes as well as the protected routes. And if anyone wants to contribute, I do have an extensive documentation on the main repo, or you can see my GSOC website on the GSOC website in my final report. I do have what are the errors currently using the Finirect client. I've documented all of it, as well as how you can set up the React web app on your local machine and how you can use it. I have documented all of it. If you have any errors, you can contact me, obviously. But yeah, all of it is documented. As for future work, we have some pages which need better backend integration, especially in the institution module. There are some pages which were inaccessible in the original web app. It may be due to different bugs. They can be implemented in the future in the new React web app. Also, adding unit tests for the React web app would be better, as it would improve the code quality much better, as well as multi-language support. Currently, it is in English, and obviously Mifos does have support for multiple languages, so that would be better, as well as contributing. Anyone who is interested in contributing to the React web app can do so. I do have the documentation as well. Now let's go to the demo. So this is the new React web app. Obviously, all these pages, including the dashboard, all of this I had shown during my midterm evaluation, navigation, all of this is connected to the Finirect backend. Other than this, I was working on the admin module, which has the users, organization, which has multiple sub pages in it, including, let's, for example, take manage offices. You can create an office. You can see the office as well as edit the office. Same with different modules here. You can manage holidays. You can select for which office, and it works like the original web app. Other than this, we do have systems module, which are managed data tables, managed reports, and we get the point. We have all of these pages which have been integrated and they have been connected to the Finirect backend. As well as in the products, you have the loan products, you can create it, you can view it, as well as there are some errors in the OpenAPI descriptor. I have noted down all of them where there are certain places where the data is missing so that it can be improved in the future. We have the reports, which can be sorted as for your clients, loans, etc. As well as the accounting module, which has closing entries, frequent postings, chart of accounts, create journal entry, search journal entries, accounting rules. Then we have the institution module, which has the centers. All of this is connected to the backend. We have the groups module. The groups module has saving account. You click on it. This is also hooked up to the backend, as well as you have the clients module, which contains the loan accounts, all of the different tabs, which have been also integrated with the backend. All of these sub pages have been created, as well as if you go to the clients, we have savings accounts here as well as the shares account. So all in all, that was my presentation for the new React web app. I hope people can contribute to it and also improve it so that it becomes a much better web app in the future. Also, I would like to thank the Mifos community, my mentor, Alex, Ed, David, and everyone who supported me through this journey. And yeah, thank you for this opportunity.
Thank you, Craig. Really impressive all that you were able to accomplish throughout the summer. And I think for the community, one of the major next steps and what we'd like to demonstrate is how, now that we have this more modular UI framework and tool, how different UIs could be built out for different fintech use cases. So Craig focused on replicating the entire web app as a whole, but the end goal is to have this in place now such that if you just want to build out a lending app or some type of fintech app or a wallet application, you can just pick and choose and use those components that you have. So we look forward if there's any community or ecosystem members who'd like to work directly on the code base that Craig has implemented, we can, help guide you in making sure you get the best experience using this new UI that Craig has built. But thanks again, Craig. Next up, we're gonna shift gears to more of the modules on the Mifos X backend that relate to credit decisioning and loan risk assessment. So we're gonna pass it on to Abhinav now, who's gonna go through the React-based loan risk assessment tool that he's built to help unify the different components we have out there to help credit risk borrowers more appropriately. But on to you, Abhinav.
Thanks, Ed. Hi, everyone. I'm Abhinav Cilanki. As part of GSOC, I worked on the reactive loan risk assessment engine for Mifos X, and I've been mentored by Victor Romero and Akshat Sharma. I'll be walking you through the following things. Firstly, we'll talk about the need for my project. Then I'll be walking you through a live demo and showing you the working of the application. Followed by which I'll be talking about the features of the loan risk analysis engine that I've built. After which we'll also talk about the shortcomings in the application and some future work. So firstly, the need for the project. 2024 survey suggested that 78% of lenders use credit report data as a major form of risk assessment. But also around 31% feel that traditional credit reports don't paint a complete picture of a consumer's finances. And in this survey, there was also a response that 90% believe that greater access to alternative data like bank statements and income reports would help them tap into new markets of interest, like customers who are new to credit. But however, only 43% of lenders currently supplement credit scores with alternative data in the risk assessments. And the source of all these metrics is in the Nova Credits 2024 survey. You can find it in the presentation. Right. So we looked at the stats. And as part of this, I've implemented both credit bureaus and bank statement analysis as solutions to analyze the risk of a loan application. So the credit bureau fetch the credit scores of the applicant from credit bureaus like Experian, Equifax, and TransUnion, which are the major credit bureaus. And we have currently configured iSoftPull, which is a third-party service to fetch these credit scores from these credit bureaus. And as part of implementing the bank statement analysis, I've used ARIA AI's APIs for performing the bank statement analysis. Right. So I'll give a live demo now. We'll be firstly creating a client, then we'll add the client's credentials, which include the address and the identities. Following which we'll create a loan application, we'll upload the bank statement as a loan document, and finally we'll see the results. So I already have FinReact running and also the web app running, as well as my application. All right. I'm currently using a sandbox to test out the calls, and as part of that, I'm supposed to use loan applications or basically user credentials that support sandbox. And so we'll be creating one that supports the sandbox of iSoftPull. Okay, the head office, and let's see, the first name is Susie. Last name is Q. And I guess these are enough to create the account. Right. So now an active account has been created for Suzy Q. And next we'll add the address under the address tab. So go ahead. Okay. I think in the address, city is this, province is California, yep. Country is United States, and the postal code is this, right? And we'll also create an identity that is required for the credit bureau. ID, active, document key is this, right? And social security number. All right. So the identifier has been created as well. Now we can go about creating a loan application. This person today. Yeah, I'm just skipping through these steps to just create a simple loan account for now, but it's configurable. Right. So a loan application has been created. And I guess, so what happens now is FinRack publishes an event to Kafka. This job runs around once every minute. So I guess it will take a bit of time to reach our application through Kafka, but it should reach in a while. We can check the event being received here as well. But I guess in the meantime, we'll also have a look at another we'll create another loan just to make sure that it's working for them as well. So this is another account for one of Steve Johnson's, and I'll be creating another loan account, loan application. All right, so filled up. Did I choose the right one? No. Right, created another application. And yes, so the snapshot has been saved for the first application. We'll go ahead and upload a bank statement for them under loan documents. Yeah, so this is a mock bank statement which my mentor provided to me. Yep. Now that this has been uploaded as well, the event will reach FinRack. Similarly, let's upload a loan document to this as well. Right. Right, let's see. It's not received it yet, but hopefully soon. Yep. Right. Okay. The first loan has an ID of 2050. Let's look at the dashboard. 2050. Yep. Okay. So I guess the bank statement analysis has had a failure. Okay. For Suzy, for some reason, the bank statement analysis was a failure, but the credit bureau was a success. Right. So we can see for Suzy, the credit bureau pulls indicate that under the Experian Credit Bureau, the for the FICO score model 2, their score is 560, and we can look at the detailed reports as well. So there are also reason codes as to there are too many delinquent or derogatory accounts and other such things, too many recent delinquencies, the reasons for why their score is so low as well. Right. And let's look at the other one to show the result. Yeah. So this is the bank statement analysis report that has been generated. And you can see that detailed insights are provided about the bank statement as to how their financial behavior is great, and they have a strong focus on sustainability and responsible financial management. So all their accounting is given over here, and you can basically find a verdict as to whether this candidate is credit worthy. Right. And you can similarly find their credit bureau report as well. So this person has a better credit score of 732. Let's look at one of their reports as well. Yeah, so you can also see the reason codes that amount owed on accounts is too high or too many bank or natural revolving accounts. But yeah, this person has passed the credit check. So yes, this was for the demo. Similar reports are generated, but as I have only one bank statement, I'll be uploading it for both the applications. Right, okay, let's talk about the, okay, let me get back to the architecture now. So firstly, FinRact emits events to Kafka, and our application is consuming those events from Kafka. These events are like either a loan event, or if a document has been uploaded, a document like the bank statement has been uploaded. And then the major logic is present in the aggregator, where it checks for all the requirements for our loan application to be sent to third-party services. So the aggregator populates all our API requests, and after that, it makes non-blocking HTTP calls to the bank statement analysis and the credit bureau pull. Right. So this is an overview of the architecture. I'll talk a bit about the features of the loan assessment engine. Firstly, this is an event-driven microservice. We're using Kafka to decouple FinRact from our application. And uh, the major benefit of this is real-time processing. And one of the major reasons for using Kafka instead of any of the other message queues is that Kafka can persist events, and we usually persist events for 7 days before discarding them. Then talking about transactional persistence. So let's say that our application received a loan created event, but due to some error, it was not able to process it. And as a result of that, it has to populate, let's say, two separate tables. One of them is the snapshot table where we store all the details about the loan, and the other table would be created in the aggregator where we maintain states about the different risk analysis processes. And we wouldn't want any kind of records to be populated incompletely. As part of that, I've introduced database transactions so that all of this happens as a single transaction and there are no incomplete records created. Then I've also introduced automated retries and daily processing. So as we saw just now that one of the bank statement analysis failed. But what happens is I'm storing currently. So if you can see over here, event message in this table, I'm also storing an attribute called is processed, which checks whether the entire process has been completed. So if we see that a failure has occurred for one of the processes, we retry it at the end of the day. So this ensures that we don't have to manually go about and re-upload things. The application basically does it for you at the end of the day. It's like a cron job that runs. It checks which events have failed and it reruns that. And yeah, we are using reactive calls to send to third-party applications. As part of this, we can send multiple requests concurrently. And yeah, We can send multiple requests concurrently. As a result, scalability will be better. Also, it is easily configurable with other third-party services, not just ARIA AI and iSoft Pull. So it's an easy interface that you can integrate with other third-party services as well. Right. Yeah, this is just an overview of the database tables. The aggregator is the major table that stores like the states of all the processes, the documents uploaded and such. And the others are to store like the metadata as well. Also, we are reliant on FinRack on making API calls to FinRack to fetch documents. The sheer size of the bank statement analysis documents requires us to make API calls, and it cannot come as part of the event. Yeah, we are storing them locally as well. The documents, bank statement analysis documents we receive. So talking about a few shortcomings, I just mentioned that we are reliant on FinRack. We are reliant on FinRack to make calls for fetching the bank statement analysis, the addresses, and the identities of the borrowers. So one thing I found as a shortcoming was that since I was running FinRack locally, I was not able to make a lot of parallel requests. I was trying to use Webflux to make parallel requests, but FinRack was just giving a failure when I tried to make multiple calls. I think this can be addressed by creating events for the address and the identity, for fetching the address and the identity through events. But using for fetching the bank statement analysis document, I think we have to look at building a separate pipeline, and I think this will be part of the future work. Also, another shortcoming was that I was not able to load test the application. So load testing would involve having thousands of calls, thousands of events incoming from FinRact, and uh, our application processing it and making third-party calls. But testing this would be in the future scope, and it was not a part of this phase. Right. Also talking about the costs that we incur on making every call. ARIA AI typically charges about 56 cents per successful call, and iSoft pull calls are also about $2 to $5 each. So careful budgeting and also caching has to be done so that we don't repeat any of the requests we're making. Right. So coming to the future work, another report by uh, TransUnion Civil Credit Market Indicator report. It suggested that new to credit borrowers are around 15 to 20% every year, and customers who are new to credit and new to the organization will also require the Know Your Customer ID verification service. And this would also be very essential for digital lenders. So I think this would be a very good addition to our services, which you're offering as part of the loan risk analysis. And solutions to that are native to Mifos, such as the bank statement analysis engine, which one of my co-interns is also currently developing. I think he'll talk about this after me. So I just felt that in order to reduce the cost overhead, we could use something that is native to Mifos, and this will actually save a lot of cost, and also we'll be able to provide a better suite of solutions. Yes, and one other thing we can implement is the automatic rejection of very weak applications. So as you saw, we are currently going to a dashboard and we are having to manually check like which loans to approve or not. So that will be a manual job on the FinRact side. So instead of that, we could add like an event to be emitted by our application to FinRact, so that FinRact consumes that and it automatically rejects events that have a very low credit score or something like that. Yeah, basically any red flags that our analysis pointed out, we can send it to FinRact. Right, and I had a very wonderful experience contributing to the Mifos initiative. It has helped me grow professionally and build state-of-the-art skills and improve my critical thinking a lot. I really thank my mentors, Victor and Akshat, and also the entire Mifos community for facilitating this. And also, I got a chance to connect with people across the globe and understand how things work globally, how softwares are built. So I'm very grateful for that, ever grateful. Thank you.
Okay, thank you so much, Abhinav. Very impressive all you were able to achieve throughout the summer. And thank you for that comprehensive presentation, which went through, the need for it, the design of it at a technical level, an interactive demo, and those shortcomings and next steps, and looking forward to hopefully being able to integrate those other, services like bank statement analysis module, the credit bureau work that you is going to showcase next. And glad that we have this very powerful tool that hopefully we can ensure others in the community are aware of and can begin to adopt. And I know you're going to be busy at Stripe, but hopefully you'll be able to continue contributing and being a
Yeah,
valuable
I'll
member of the
definitely find
community.
time for contributing to this application. I
Okay,
definitely have an
thank,
attachment towards this.
good. Well, thank you so
Thank
much, Abhinav. So next up, Yu is
Thanks,
going
sir.
to present her work around the next iteration of our credit bureau integration module. So on to you, Yu, and looking forward to all you were able to accomplish with the support of Victor and others.
So this is Credit Bureau Integration Plugin Phase 5. My name is Wati and my mentor is Victor Romero. And this is like continuing on about the credit checking feature for Mifos X. So the contents I'm going to go through is the big picture of why this is needed and a high level architecture of how I built this, the technology specifications that I use, a little deep dive into the code so that other contributors know where to find the information, and a typical workflow, like how it's going to work and how we're going to build, run, and test, and some future work that that is needed for this work. So the big picture is, so what is the credit bureau? It's data furnitures and also known as the consumer credit reporting agency. They get the data from about a consumer from all parts of the place, like either a hospital, a store, things like that. And they furnish them together and create a credit reports that banks and other financial institutions can use. And why we want to integrate Credit Bureau and Mifos X. If we do that, we can determine and approve a client's loan application. We know like what is the credit score about the client, so that in the future we can prevent bad loans. And it's also like a feature that can be make loan processing more smoother for Mifos X. And this is phase 5 because I'm building the work from Google Summer of Code 2016. And this is the high-level architecture. We have the Mifos X platform, and we have this credit bureau integration service that I'm building, and then the other layer is like multiple credit bureaus that we'll be able to send a request to get a report. So my integration service like is at the middle, it's like act as a connection between the existing platform and then multiple credit bureaus, like not just one. This is like the technology specifications. Like I'm using Spring Boot 3 and MariaDB database that is containerized with Docker, so it's easier to run. And I'm using Spring Data JPA and Liquibase for like database schema management. And the API layer is a mix of both the Spring Web and Jersey. And I'm also using OpenAPI to do the documentation. It's currently a work in progress. And the build tool is with Gradle and testing is JUnit 5. I've made this a bit similar to Apache FinerX technology because like just so that like in the future, if we want to merge this back into Apache FinerX, it'll be more smoother. And this is like just my file system for the code, and it's kind of like a basic layered architecture. I use API, which exposes the API that I've built. It handles the incoming HTTP request and exposes the REST API. And a service layer that contains the core business logic, a domain layer where I have the core entities and repositories, and the data data layer, which is contains the DTOs for API communication, and a mapper to convert between data and entities. And exception handling is for error handling, like for example, we're unable to find credit bureau data, like what will happen next. So that is what my file system looks like. And then more about the code, I'm using the repository pattern. So I use the repository before I make changes to the database. And I'm using the DTO pattern as well, just so that I can decouple the API and from the internal entities. And the main purpose is to make the APIs more secure. And I'm using map struct to map between an entity and a DTO, so that it's easier to implement, like configure new credit bureaus into the code. And a builder pattern also to make it easier to configure new credit bureaus. And what I also added is an externalized configuration, so that I'm going to be storing the API keys for different credit bureaus in my code, so that it's easier to configure new credit bureaus. And so how are we gonna add new credit bureaus is we just create a related request DTO for that external credit bureau API. And then we create a DTO for the response, and we create a few related services. And that way, it's gonna be much easier to bring in more credit bureaus to get credit scores and reports from multiple credit bureaus. And this is important because Mifos is a global organization with many different locations, and each location has its own credit bureau. So if we're not just attached to one credit bureau, like it'll be much easier to integrate it into different countries and locations. So I'm gonna demo like the main parts that I've been working on. So I've just built the API. I don't really have a front-end implementation of this. I've used Figma to explain like what these APIs does. And the first part of what we're going to do is to register a new credit bureau. So I'm planning to put this registering for a credit bureau in the systems part of the Mifos X platform. So here we're going to choose a new credit bureau. And after choosing a new credit bureau, like we'll have these choices are going to be the credit bureaus that have already been configured in the credit bureau integration service, meaning they already have their DTOs and their services. And from them, we're going to choose Circulo di Credito, which is what's currently working as of now, the connections that's currently working. And for Circulo di Credito, you'll have to have a few API keys that you will register externally with the company itself. So if you are a banking officer who's using Mifos X, you'll have to externally connect with Circulo di Credito and then register these API keys with them externally before you store them here. So this is basically just storing what you have externally registered. So after this you store it, and that's it for registering. And now after registering, like we're going to view the credit report of a client. So this is the client page, and under the credit bureau header, we'll choose a credit bureau again. And here we have only registered Circulo di Credito, so that will be the only choice. And after that, this is the credit report response from the Circulo di Credito for sandbox request. So this is a person doesn't actually exist. It's just part of the sandbox. And that is it for the demo. And this is just an explanation of what happens behind the scenes, like a data flow of what's happening as we're registering and doing the credit report. So it's like first, the users do the registration. They call the information about the configured credit bureaus, and after that, we get these keys that the user have entered, and these keys are secrets. So, and we use the encryption service, which I have used the AES encryption, and we're going to store these keys in a database table. And later on, when we want to view the credit report, the Circulo de Credito Fico Score request service, it's going to call the keys from the database, and it's going to have a signage service because Circulo de Credito has its own, like we have to create our own signage using the body and the keys so that the API hub recognizes this as something that has been registered already. And we also make a call to FinReg client API service because that's where the information about the client is. So we make that call, we create the header and the signage, and using that combined request, we send that to Circulo de Credito. And from Circulo de Credito, we get, if it's properly registered with them, we get a response back. And with that response, we want to transfer it to something that is more generalized and put it back to the Mifos X platform. And next this is the setup for my code. You can git clone it, and you can set up Docker to set up MariaDB database. But later on in the Docker YAML file, you can change it to Postgres if you wish. And you build it, you can run the test and you run it. And I have some authorization for the username and password, but it is part of the environment in the Postman collection I published, which I will show you later on. So this is the Postman collection that I have published. You can take a look at it as well. It contains like all the APIs that I have configured and then built for this. And I have also made a description for every one of them. So hopefully like it's easy to understand like what they are doing. So as for the future work, I have a document in my GitHub, which is like a to-do list. Like I've been reviewing my own code as well and seeing like what is needed, like doing some external research to see like what could be made better. So I have just made a list of a few issues that I have found and a few things that would be good to implement. And you can find that in the repository in the to-do documentation. And for more future work, my credit bureau module is currently a single tenant, which is not going to be very useful with the whole Mifos X platform because there's so many users. And I'm currently writing and reading straight to the database, and caching is not implemented yet. But if we could implement it, like it will be really good, as it'll make like, because we have many users, and it will make it much more faster. And I'm using AES encryption, and that might not be the most secure method. I found out that there's things called AWS Secrets Manager and HashiCorp Secrets Manager, things like that. So using them may be actually better for us, like better for the security of this project. And right now, the credit report is not really mapped to a loan product, so there's not really any automated decision making on whether a loan can be made. And more information about this project you can find on my Jira and my Gist, where I've also listed all the APIs that I've created and more information about the architecture. So this is all for my presentation. Thank you so much. Thank you to Ed, David for organizing Google Summer of Code, and thank you to my mentor Victor Romero, like whom I learned a lot from. And the few references I used is Nikhil Power's proposal from GSOC 2016, Oracle's Bureau Integration Service blog, like to develop my architecture. a blog called Symmetric Encryption. That's how I learned how to implement the AES encryption for the secrets. And I also used Fineract Academy to understand how Fineract works. And that's all for today.
Thank you very much for you. That's absolutely great. Often when we're talking to customers, credit bureau integration is one of the hottest topics that they come up with. So it's really important to get these improvements you've done back to the Mifos X code base. So thank you very much for the good work you've done this summer. Now we'll move across to Priyanshu. Priyanshu has been looking at the bank statement analysis module and been working on that this summer. So Priyanshu, do you want to share your screen and take us away?
So hello everyone, Namaste. My name is Priyanshu Tiwari and I am deeply passionate about to leveraging AI/ML technologies into the real world problem solving. And this led me to work under Mifos initiative through Mifos Summer of Code and parallelly working under Google Summer of Code under INCF. So today I am honored to presenting my project Bank Statement Analysis Phase 2, which is completing which I have completed under the exceptional mentorship of Akshay Sharma sir, who is a technical advocate at Deskry. So let's wait a second. Yeah. So let's come to the project overview. That vision of the project unified the platform to aggregate and analyzing the transactional data from the multiple sources, bank accounts, and investment and payment processors. That core value of our project that provide the real-time insights about the spending, anomaly deductions, and debt management. And the key feature of our project that fully based on NLP and ML and also integrated with the AI and LLM parts, that ETL pipelines that clean transform data, ML engines that predicting power categorization and anomaly detections, recommendation engines delivers the personal financial goals and as well as personal recommendations. And we have also created an interactive dashboard with logging facilities. So let's come to the technical architecture and stacks. Technology we are using HTML, CSS for the just styling and Plotty for showcasing the plots and visualization. Streamlit is the main GUI, Hugging Face that we are using some models, and ChatGPT as an that LLM API, and also PostgreSQL to store the credentials and login credentials. So this is our architecture of the project. User logging interface, financial data, standardizing that statements and analyzing the spending of the users and goals and generating the personalized advices, and also showcasing the many plots about that financial expenditures and display the insights and recommendations. So come to the core algorithm one of the data intelligence, how we have developed that specific model, that hybrid transaction classification. It is based on the regular expression, which is I have showed here as in a theory of computation based, how it's working. And it's also helped to predict and detect the fraud detections and anomaly detections, like algorithms, isolated forest, unsupervised learning model in the NLP, that performance is around 87.5 detection rate, with the F1 score is 89%, identifying the usual spending patterns, potential frauds. So let's come to the core algorithm 2, that predictive analysis of the main backbone of our bank statement analysis, that loan eligibility, that we are using XGBoost for the major bank statements, and also we have integrated random forest and LSTM for getting if XGBoost fail, that will come as in fallback mechanisms. Key feature of that income stability, debt income ratios, that performance was very good of XGBoost is around 93% with 22 more than better from the logistic regression last year has been developed. That financial health score, that becoming a composite 0 to 100, evaluating the all financial goals with insights of 18% of user scores with the 70% healthy scores. So this is our algorithm algorithm flow chart. So let's come to the interactive dashboard and user insight. That technology we have developed by using Streamlit, Plotty, and visualization. That key visualization is there about spending trend analysis, breaking downs, then financial health score, anomaly alerts, and saving goal and tracking. So these are the some proof of concept of project, that how it's detecting and showcasing. And it is a AI powered Mistral based LLM that generating the financial health score as per the incomes and as per that things. Yeah. So this is a financial health score. It is showcasing the whole bank statement analysis as a health score. Like you can see here, as in transaction diversity is very high in this, especially bank statement. So these are the some more figures that you can see. You can see that detailed analysis, anomalies, and AI-driven power platform. That transaction accuracy is around 94%. Cash flow prediction is 35%. Processing speed is 2.1x, and user adoption rate is 76%. So impacts and key finding of this project, especially that automated, personalized, and promoted the health finance habits also, and come up to the limitation that especially rent limitations is there because it is high computational, and open banking integration is little bit difficult with the future upcoming project to integrating with Apache FinReact and also with Mifos Kotlin multi platforms. And let's come to the main final video demo of this project, like how we are logging in this interface and just putting the many multiple bank statements. It will read and it will fetch the data within a seconds. You can see. You can see we have shipped it all in one in bank like that. We have put it. So as I'm a IEEE and Springer researcher with consisting 9 papers, I have got honor to presenting this project as a research because we have created our custom XGBoost with the modified batch matrix. So that's why we have presented this project as a research paper in the Asia's largest conference at IIT Indore under the mentorship of Akshay sir, Himanshu sir, Rahul sir, Edward sir, David sir, and Rajan sir. And special heartfelt thanks to my Mifos initiative who have guided me and supported me throughout this journey. Thank you.
Thank you very much, Priyanshu. That's a great piece of work and some very interesting findings you got as well at the end of that. So it was interesting to see that you've done that extra step of analysis and got findings. So yeah, thank you very much. It's good to see that you know presented that wider as well to the outside community, getting a bit more interest in our programs and our internships, as well as sharing the knowledge outside our DPG. So it's great to see that effort occurring. Now I'd like to move to Hossam, who's been working on the workflow engine integration module. Hossam, over to yourself.
Hello, everyone. First of all, I'd like to thank everyone in this wonderful community for the very exciting Google Summer of Code journey. And here I am sharing the final progress on my Google Summer of Code project, integrating Mifos X with workflow engine and process automation tool. Let me start by outlining the core problem we are addressing. Currently, Mifos X lacks a built-in flexible workflow management system specifically designed for loan and customer onboarding processes. This creates several significant challenges for financial institutions using our platform. The current workflows require technical expertise to modify or create, which severely limits access for non-technical staff. Imagine a loan officer who understands the business requirements perfectly but can't implement workflow changes because they need to write code. We are missing that intuitive drag and drop user interface that will allow users to design workflows visually. Without this, every workflow modification becomes a development task rather than a business configuration. There is no seamless integration between internal processes and external systems. This fragmentation means that workflows often break at integration points, requiring manual intervention. These limitations result in manual processes that lead to insufficiencies, slower customer onboarding, and unfortunately higher error rates. So in today's competitive financial service landscapes, this impacts the user experience significantly. The solution lies in integrating with modern workflow engine like Flowable, JBPM, or Temporal. So our goal is clear: empower users to define workflows visually and independently, enhancing flexibility, speed, and usability across the platform. Now we have identified the challenges, so let me walk you through our comprehensive solution approach. The key insight here is that we are not just looking to integrate Flowable and call it an integration. Instead, we are building for the future with a modular workflow integration strategy that introduces a flexible abstraction layer to decouple Mifos X from any specific workflow engine. Let me explain why we are starting with Flowable, and then I'll show you how our architecture ensures that we are not locked into this certain solution. Flowable is our initial choice for several reasons. First, it has tremendous open source strengths with an active community that ensures continuous improvement and long-term support, which is something crucial for project sustainability. Also, its PBMN 2.0 support is exceptional, providing those clear visualized workflows that non-technical users can actually understand and work with. And of course, its Java and REST API integration capabilities make it natural fit for Mifos X existing architecture. Also, we are implementing a factory pattern design that allow us to dynamically select the workflow engine at runtime based on configuration. Think of it as building a universal adapter, just like you can switch between different attachments on a power tool or something. So our workflow engine layer let us swap between Flowable, Temporal, Orcs, or even AWS step functions without disrupting the core Mifos X code base. And this architecture means that as a new workflow engine emerge or as organizational needs change, we can adapt by simply updating a configuration file rather than rewriting the whole integration code. The user-friendly workflow design capability through Flowable's drag and drop interface, we are finally enabling non-technical users to define workflows visually. No more coding required for business processes change. By this, we will be able to automate critical processes like know your customer verification, MLTF compliance checks, and payment processing. This enhanced automation directly translates to improved speed, accuracy, and regularity and compliance. Now, let me show you exactly how this architecture comes together in our solution. Looking at this diagram, you can see layered approach we have designed. Let me walk you through the data flow and architectural components. Starting from the left, we have our controller layer with the REST API endpoints. You can see authentication controller, client onboarding, client to transfer, and the client offboarding, and more other controllers like loan origination, loan disbursement, and loan cancellation. These represent the key business processes we are automating. These controllers communicate with our service layer, specifically the workflow service, which acts as the central orchestrator. This is where the magic happens. The workflow service doesn't need to know which workflow engine it's talking to. The workflow engine factory and workflow engine interface in the center. This is our universal adapter I mentioned earlier. The factory pattern allows us to dynamically instantiate the appropriate engine implementation based on configuration. On the right side, you can see our engine implementations. Currently, we have Flowable Workflow Engine fully implemented, connecting to the Flowable engine with MySQL database. But notice here that Temporal Workflow Engine slot mark it as future implementation. This demonstrates how easily we can add new engines without touching the core architecture. The system also integrates seamlessly with external systems through APIs like FinReact, ensuring we can handle complex multi-system workflows. Now let's deep dive into the heart of our architecture, the abstraction layer. Looking at the flow diagram on the right, you can see how our workflow service communicates downwards through our abstraction components. Let me break down each key component and explain why this design is so powerful. First, we have the workflow engine interface. This defines our contract. It specifies all the generic operations for workflow management that any engine implementation must support. Think of it as our universal language that every workflow engine must speak. Whether we are talking to Flowable, Temporal, or GBPM, They all communicate through this same interface. Next, the workflow engine factory. This is our smart dispatcher. Using the factory button, it reads configuration settings and instantiates the appropriate engine implementation at runtime. The beauty here is that switching engines becomes as simple as changing configuration parameter. This brings us to what I call our engine agnostic design. As you can see in the diagram, our factory can instantiate flowable implementation, temporal, or other engines seamlessly. This system doesn't care which engine is running underneath. It just knows how to communicate through our standardized interface. By this, and why does this matter? Let me highlight the core benefits we have achieved here. We have decoupled business logic from specific engine implementation. This means our loan onboarding logic isn't tied to Flowable's API. It's written against our interface. If we switch to temporal tomorrow, the business logic remains unchanged. This design enables much easier unit test and mocking, and perhaps the most important thing that we have built a flexible and future-proof architecture. As a new workflow engine emerge, maybe there is a revolutionary new engine next year, we can integrate it by simply implementing our interface. Now, here it comes to the part where we connect with Fineract, the core banking engine that powers Mifos X. First, we are using auto-generated client library. This is not just convenience, it's a game change for maintainability. The client library is generated directly from Fineract's APIs specifications, which means that we get type-safe, maintainable communication with Fineract APIs automatically. When Fineract updates their APIs, we regenerate the client and our integration stays current without any manual updates. You can see our workflow service communicates through the Fineract client service, which then distributes requests across different functional areas. We have implemented reactive programming using RX Java. This is crucial for workflow automation because financial processes often involve multiple sequential API calls. Think client creation, document verification, account setup, and initial deposit. With RX Java and reactive programming, these operations run asynchronously and non-blocking, meaning our workflows can handle multiple client onboarding parallel without performance degradation. Now let's talk about something absolutely critical for production workflows, the error handling strategy. In financial systems, robust error handling isn't just nice to have, it's essential for maintaining data integrity and user trust. Looking at our flow diagram on the right, you can see how we have designed a sophisticated error management system that handles failures gracefully at every step of the process. We have implemented a multi-layered error management approach with specialized handlers for different types of failures. Our global exception handler provides a centralized exception handling across the entire application. This ensures consistent error response and prevents any unhandled exceptions from reaching the user without cryptic technical messages. The workflow error handler message, workflow specific error pattern. The sire part is our Fineract error handler, specifically manages API integration errors. Since we are making multiple calls to Fineract APIs, we need intelligent handling of network timeouts, authentication failures, and data validation errors. And this shows how we categorize errors into workflow exception, Fineract API exception, and runtime exception. Each type gets handled appropriately. We are also using RFC 7807 compilant, which means our error response follows standardized formats. This ensures that our automated workflows are resilient, maintainable, and provide clear feedback when things don't go as planned. Now, let's look at the implementation of our solution in action, the client onboarding BPMN 2.0 process. This workflow streamlines new client registration and activation, transforming what used to be a manual, error-prone process into an automated, consistent experience. Looking at the BPMN diagram, you can see the flow. We are starting by creating an inactive client record, then move to manual verification of client data, documents. After verification, we have the session gateway. If approved, we assign stuff and activate the client. If rejected, we handle the rejection gracefully. The entire workflow and next workflows can be designed visually by business user, modified without code changes, and executed reliably at scale. What previously required multiple system interactions and manual coordination now happens automatically without full audit trails and error recovery. Our second workflow example is client transfer between offices, a process that traditionally involves significant paperwork and coordination. Looking at the PPMN flow, we have a streamlined process. Select destination office and propose transfer, submit the transfer proposal automatically, then manager review and approve with clear accept or reject paths. The workflow integrates directly with the FinAct offices and the client transfer APIs, ensuring data consistency across the system, like our onboarding process. Our final done workflow for the client workflows is the client offboarding, managing account closure with proper validation and compliance. The BPMN flow shows a sophisticated validation process. We start with the precondition verification and account status check. The decision gateway routes to either the closure path, fetching closure reasons, confirming the reason, and closing the account, or to handling pending items that prevents closure. Now let's explore our most comprehensive workflow, the loan origination BPMN 2.0 process, which transforms the entire loan application lifecycle from submission to approval. Looking at the sophisticated workflow diagram, you can see how we have automated what traditionally require multiple manual touch points and coordination between different departments. The process begins with loan application submission and moves through our multiple-step workflow with comprehensive application review and the credit assessment. Notice the hierarchical approval system with manager oversight. This ensures proper governance while maintaining efficiency. What makes this particularly powerful is our dynamic additional information requests and collection capability. The workflow can intelligently pose request additional documentations from applicants and resume processing once requirements are met, all without breaking the process flow. The integration points provide seamless connectivity to FinAct loan creation, approval, and rejection APIs, while our robust validation and review cycles ensures data integrity throughout the entire process. Following the successful loan approval, our loan disbursement PPMN 2.0 process takes over to execute approved loan disbursements with a comprehensive verification and control mechanism. This workflow showcases our commitment to security and compliance in financial transactions. Starting with pre-disbursement verification, we perform automated loan status validation and readiness checks to ensure all prerequisites are met before any funds are released. The approval workflow includes manager review and approval for disbursement execution, adding that crucial human oversight for high-value transactions. Our comprehensive document management handles document preparation and compliance verification automatically. Notice the sophisticated error handling with IT escalation and automated retry mechanisms for failures. In financial disbursements, reliability isn't optional. Our system ensures that temporary failures don't result in lost transactions or incomplete processes. The workflow can gracefully handle the network issues, system downtime, and integration failures with appropriate escalation and recovery procedures. Our final core workflow is the loan cancellation BPMN 2.0, which manages loan cancellation requests with proper validation and approval controls, a critical process that requires careful handling to maintain data integrity. The workflow begins with automated loan status validation for cancellation, ensuring we are not attempting to cancel loans that are already dispersed or in states where cancellation isn't appropriate. Our multi-level approval system includes review and approve workflow with impact assessment, allowing managers to understand the full implication of the cancellation before approval. The dynamic additional information collection and validation ensures that we have complete documentation for audit purposes. The comprehensive validation checks with rejection notification handling means that inappropriate cancellation requests are caught early and handled gracefully, with clear feedback to users about why their request couldn't be processed. Here are some demos. Now let's deep dive into the technical implementation. Our organized Spring Boot app with layered architecture design that makes this entire workflow system possible. Looking at the project structure, we can see we have implemented a clean, maintainable, Maven-based Spring Boot application with a standard package organization. This isn't just a good practice; it's essential for very long-term maintainability and team collaboration. Our API layer provides RESTful controllers for workflow operations and external integrations, while the business logic layer contains our service layer with core workflow engine and business rule implementation. The integration layer houses our FinAct data transfer objects and the flowable engine integration components. Notice our comprehensive approach to configuration management with centralized config classes and application properties. This allows us to easily adapt the system for different environments and requirements without code changes. The process definition stored in the resources/processes directory contain our PPMN workflow processes, and our comprehensive testing structure ensures reliability with post-unit and integration tests. This technical foundation is what enables the complex workflows we have demonstrated. Here is where the magic happens for the business users. The flowable modular interface that enables visual workflow design without any coding knowledge. Looking at this screenshot, you can see our final loan origination process being designed in the drag and drop interface on the left. We have our comprehensive plate and tools of BPMN elements, start events, user tasks, service tasks, decision gateways, and more. The visual workflow designer allows business analysts and loan officers to modify existing processes or create entirely new ones. They can drag elements from the sidebar, connect them with sequence flows, and configure properties all through this intuitive interface. This is how the process definition properties at the bottom allow for detailed configuration without technical expertise. This democratized workflow design, moving it from the IT department directly into the hands of the business users who understands the requirement best. This visually approach means that when business requirements change, and they always do modifications can happen immediately without waiting for development cycles or technical resources. Now, this is our comprehensive REST API that make this workflow system programmable and integratable with other external systems. Our Postman documentation here shows the full range of workflow operations we have exposed through clean RESTful endpoints for client transfer and onboarding, loan origination, and all the workflows we have implemented along the journey. Notice that we have a well-structured endpoints organization and comprehensive request response documentation and there are many examples here. This API first approach means that our workflow system isn't just a standalone application. It's a workflow engine that can be integrated into existing banking platforms, mobile applications, or third-party systems. The auto-generated client library I mentioned earlier ensure type-safe integration for consuming application. Here it comes to the most interesting part, which is the documentation. It's a crucial part for adoption, and we have created comprehensive ASCII doctor documentation that covers every single aspect of our workflow system. Looking at our documentation structure, you can see we have organized everything from high-level overview and key features down to specific API references and workflow process details. The documentation includes the system architecture explanations, layered architecture details, and our complete technology stack. Our quick start guide with prerequisites, Docker Compose setup, and manual installation instructions ensure that every developer can get up and running quickly. The configuration section covers the application properties, environment variables, and database setup. Finally, let's discuss our production-ready deployment strategy that ensures our workflow system can scale and perform reliably in real-world financial environment. Our comprehensive deployment approach covers everything from development to production environments. We are using containerized deployment with Docker Compose, including health checks and service dependencies to ensure reliable startup and operation. The system requirements: OpenJDK plus 21, MySQL plus 8, Docker plus 20 represent modern support platforms that provide the performance and security needed for financial application. As we look ahead, I'm excited about expanding this workflow integration module. We are going to implement more Mifos X workflows, and we are implementing task replay functionality, which allow administrators to replay failed workflow steps crucial for production debugging and recovery scenarios. Enhancing the test coverage is a huge priority, and we are strengthening the robust error handling across the whole application even further, building on the multi-layered approach we demonstrated early. Integrating this module with other modules like Reactive and Loan Risk Assessment implemented by my fellow contributors. Also the Credit Bureau project. We are going to add more user guides for workflow designers, which will empower business users to create and modify workflows independently, fulfilling our original vision of democratizing workflows design. I'm deeply grateful to my mentors, Edward, Yash, and Victor, for their invaluable support and guidance through this project. They continuously reviewed my work, helped me navigate key technical decisions, and pointed me towards the right concepts and resources whenever I need help. Their support was both technical and personal, and I truly appreciate the time and effort they dedicated to mentoring me. I'd like to thank the Google Summer of Code organizers and admins for their consistent and constant support in making this program a smooth and a rewarding experience. And finally, I'm committed to continuing engagement with the Mifos community, this wonderful community, sharing knowledge, helping fellow contributors, and ensuring this solution can benefit the entire ecosystem. Thank you so much.
Thank you, Hossam, for demonstrating that work. It's really important work to our community, getting that functionality built into our Mifos X modules. So thank you very much for all the work you've done on this internship. Thank you to all our participants today and our interns. It's been great to see everything you've done, the culmination of a hard summer of work for all of you. And I think you can be very proud with the outcomes that you've got and the presentations that you've been able to make at the end. So congratulations to all of you on passing your internships. And we hope to see you active in the community for many years to come still, so you don't escape that easily. We are now heading towards the end of finals week. We have one more day tomorrow of finals week. Day 4 of finals week will focus on AI enablement. So instead of our normal AI working group tomorrow, we will actually have a celebration of all the AI projects we've done this year. I think the key thing about these are they're not just AI projects for the sake of AI projects. They're really AI projects tied back to our products. So these are real AI features and real AI needs that our products and community have. So there can be a real impact and outcome from it. So I hope you will be able to join us tomorrow for our final session of finals week. And thank you for all joining today. Have a good rest of the day.